like I said, our new unit is called transformations. There are 4 types that we're going to focus on. So we've got translation, reflection, rotation, and dilation. The unit we just ended on, similarity, really focused on dilation. So we kind of already have a leg up on dilations. But like I said, those other words you have already done in previous math courses, so this is kind of review on that. All right, I'll say a letter and you tell me what happened to the emoji. A, what happened?
Reflection.
Reflection. And what is it a reflection over? What is it?
X-axis.
Yes. All right. So, what about B?
Lines.
Awesome. B is a rotation. And we talked about being 180 degrees. Very good. What about C?
Translation.
Translation. I won't make you count and tell me what type of translation it is. We'll get into that so much more during the lesson today, I promise. What about D? You can use them more than once. Yeah, it's another rotation. It's another rotation. How many degrees is this one?
90.
90. Or? Yeah, I heard that. Good.
270.
Or 270. It depends. Did you go this way? Or did you go this way? Which one was your original? Which one was your resulting image? So we'll talk about that today as well and tomorrow because rotations is tomorrow. E. What's E?
Reflection.
Reflection over what?
The y-axis.
Y-axis this time.
Dilation.
And F. What is F?
Dilation.
Dilation. Like I said, we learned about that in the similarity unit. And if I gave you some coordinates, you could tell me the scale factor, right? So how big was it, enlargement or reduction, and how big was it? So that's a dilation. Very good. So get your notes out and start writing down the words. They go in order that we have them here. So the first one, write down translation, also known as a slide. You can write slide underneath it if you want. It's another word, but the correct geometric word that we're going to use is translation. Next word on your notes page is reflection, also known as a flip of a figure. The third word is, of course, rotation, which is known as a turn. And that last word is dilation, which we call a resize. Can't call it enlargement or reduction because you don't know which one it is, but it is a change in the size, not the shape, but just the size. So when we do dilations, we're always going to produce a similar figure. So that's how similarity leads really well into this unit. Okay, so today we're going to focus on these two, translations and reflections. Tomorrow will be rotations, and next week we'll do dilations. All right, so when we transform a figure, we name the first figure one letter for each vertice. So there we go, triangle, A, B, C. That first figure we call the pre-image. There's not really a place to write this on your notes page, but you can pick one of these pictures. You can pick one of the pictures and call one of them the pre-image. And then the result, we don't name it A, B, C. We don't name it D, E, F. We name it A. What do those little things mean? Prime. We name it A prime, B prime, C prime, just like Optimus Prime and Transformers. Get it? Transformation unit, Transformers, A prime, B prime, C prime. Yeah. So the result is just called an image. So you go from the pre-image, and then you go to the image. Pre-image to image. You can see the shared screen and use that. Okay, so go ahead in your notes. There's a few blanks. There's a few blanks for the translation definition. Go ahead and fill in those blanks. A translation or a slide is a transformation in which all the points of a figure move the same distance, same direction. Same distance, same direction. I'll give you a second to fill that in your notes. Okay, so let's fill in the column that says rules. Let's fill in what the rules are for translations. So if we want to travel right, is that going to affect the X's or the Y's?
X's.
Yes, very good. So it's going to affect X in the positive way. So we're going to have X plus a number, comma, Y. We're not going to change the Y at all if we're trying to travel to the right. So go ahead and write that as your rule under translations for right. If we're going left, we're affecting the X as well, but we are subtracting from the X. So if we want to travel left, we've got X minus A, comma, Y. Once again, we're not doing anything to the Y. To travel up, we are not affecting the X, and we're adding to the Y. And to travel down, we're not affecting the X, and we are subtracting from the Y. So there are our 4 rules. All right, so let's see. So the problem says to translate triangle ABC, 5 units right and 4 units up. We know to achieve this, we can take each vertex. We don't need to do every point on the triangle. We can take each vertex and we can count 5 units right, 1, 2, 3, 4, 5, and 4 units up, 1, 2, 3, 4. We would call that point A prime. We could, of course, do that to every point. So, of course, that's how we would plot it on the coordinate plane. But how do these numbers affect our coordinates? So, we already have been given the coordinates of the vertices of the triangle. Now, what would the new coordinates be, A prime, B prime, C prime, if we wanted to go 5 to the right and 4 up? So 5 to the right. What are we affecting when we're going 5 to the right? The X values, yes. So we're going to take all of our X values and we're going to say plus 5. What about 4 units up? What are we going to do with our 4 units up? Take all of our Y values, yep, plus 4. So now we can come up with our new coordinates without even using our graph at all. So negative 5, 2 would become 0, 6. Negative 7, 3 would become negative 2, 1. 2, negative 5 would become 7, negative 1. Our rule would be a summary of what we did to our coordinates. So our rule would be x plus, 5, y plus 4. Okay, I give you a translation and you tell me what the rule is. My frog is taking a while. There we go. There's Mr. Frog. He's been translated. Find the rule for this translation. Good. So when we write a rule, we want to document, hey, what happened to the x's and what happened to the y's. So let's examine the x's first. We learned this on the first week of school. We learned how to find the distance on a one-dimensional number line from negative 6 to 3, the distance. That's obviously plus 9. If you didn't know it was plus 9, you can always subtract them. 3 minus negative 6, and you get 9. So x was moved positively 9 units. What happened to the y's? We went from 1 to negative 8. You can subtract them. Negative 8 minus 1, and you'll get negative 9. So we went right 9 and down 9. So the rule will have numbers and it will have letters from your x, y. There we go. It's taking a while for my writing to show up because the internet's having trouble today. Alrighty, let's try one where I give you words and you write the rule. Everyone go ahead and on a sheet of paper, just write your answer to this problem, and then we'll say it out loud. And go! What did you get? I think everyone is having internet problems. X plus 3 for going 3 to the right. Y minus 4 for going 4 down. All right, let's try this one. You guys can type your answers in the chat. Okay, so we need to be careful. It's not always going to be in the right order, right? 8 units up, that doesn't affect the X, that affects the Y. That is Y plus 8. So it's not always going to be in X, Y order. Very good. 6 units left means X minus 6. All right, try this one. I give you the rule and you write it in words. I give you the rule and you write it in words. All right, you did a great job. So we've got the X minus 5 means we are going left 5, and the Y plus 4 means we're going up 4. All right, we don't need to do any more of these. Let's try a challenging one. Can whoever made it describe each translation in words? So this time I didn't give you the rule. I gave you, remember, I want you to get used to these words. I gave you the pre-image and the image. So I want you in words to tell me what happened. You can go ahead and write it in the chat. This one's a little bit harder. You have to do the distance again, the number line distance. Where did you go if you went from 9 to 12? Well, you went right because this is the x's. You went plus 3, so that translates to right 3. Then you went from -2 to -7. So you went backwards 5. So that translates to down 5. Easy stuff? Easy stuff. Okay, try this one. Where did you go? Let's focus on the x's first. How far is that? -1 to 8. We like going right, don't we? Right 9, do you agree? And up 3. Doing good? One more on this page. Then we need to go to reflections. Why are they all right? How far did we go to the right? Remember, when in doubt? Yeah, when in doubt, you can subtract these. So -9 minus -15, believe it or not, that's how you would do it. And you realize that you're going right 6. And what did we do with our y's? Up 15. Okay, let's move on. We are now on reflections. You can go ahead and fill in the blanks on your notes page. A reflection or a flip is a transformation across a line called the line of reflection. I'm going to use this verbiage a lot. Line of reflection. Each point and its image are the same distance from the line of reflection. So I like to use that word a lot, equidistant. The image and pre-image are equidistant from the line of reflection. All right, so let's take a look at this. Plot points A, B, and C done for us. Reflect the pre-image across the x-axis. Find the coordinates of the vertices of the image. Do you see a pattern or a rule? So you're going to have to do this on your homework where you're taking a figure and you're reflecting it over a given line. When you do that, I want you to highlight the line of reflection. So bold it or highlight it. And to reflect this figure, you're going to count how many units am I away from the line of reflection. Then you're going to travel the opposite direction, and you're going to make sure that they are equidistant. You're going to travel the same exact amount. Okay, so right now, let's do C first, because that one's easiest. How far is C from the line of reflection? How many units? 1. It's 1 unit away from the line of reflection. So I'm going to go 1 unit in the opposite direction and call it C prime. How far away is B from the line of reflection? 1, 2, 3, 4. It's 4 away. I want to be equidistant. So I start at my line of reflection and I count 1, 2, 3, 4. How far away is A from the line of reflection? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm just traveling the opposite direction, but the same number of units. So now our new coordinates, let's see, C is 4, negative 1. B is over 1, down 4. And A is over 5, down 5. What do you notice about your original points called the pre-image and your new points called the image? What do you notice?
X, comma, negative y.
Good, you're writing the rule. Good. Look at the x's. What happened to the x's? Nothing at all. Nothing happened to the x's. They stayed constant. What happened to the y's? Well, they have the opposite sign. The sign changed. So you're not going to add or subtract anything. That's for translations. You don't add or subtract anything. You kind of multiply it by negative 1. In other words, you change the sign. You do its opposite. Very good. So what did we reflect over in this problem? What did we reflect over? What did we reflect over?
X-axis.
Yeah, we reflect over the x-axis and we change the y value, right? So when you reflect over the x, you change the y. Go ahead and write these rules down. These are your rules on your notes page. When you reflect over the y-axis, you change the x. When you reflect over the x-axis, you change the y. When I say change, I'm saying you change the sign of the x. You change the sign of the y. You make it negative. If it was a negative would become a positive.
What does y equals x mean?
That's the parent function. You know these things, right? So, y equals x is the good old parent function from Algebra 1. So it's like you're reflecting a figure over that line right there. And then y equals negative x is the parent function, but go in the opposite way. So it's like there's your point, and you reflect over that line like that.
Fail Algebra 2.
Oh my goodness, no. They'll reteach everything. So but you do need to write the rules down. Are you writing the rules down? I'll give you a few more seconds to write the rules down. Okay. So let's practice. This says, reflect the rectangle over the line y equals x. We are not going to do the thing where we count how far away it is from the line of reflection and then go equidistant. Because the problem is, how do I count the distance between this point and this line? No. There's no such thing as counting diagonally on the coordinate plane. Don't do it. Don't try it. Instead, we're going to use our rule. So the rule for reflecting over y equals x is x, y becomes, well, you just trade places. X, y becomes y, x. So our new coordinates are 7, negative 7, 7, 2, 4, 2, 4, negative 7. And then you could plot them and you would have a nice picture of your reflected rectangle. Now, because, oh goodness. So let's plot this. It is going to look a little weird. I'm just warning you. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7, 2, and 1, 2, 3, 4, 1, 2. I only apply the points because then I can connect them to make a rectangle because I know the dimensions of it. I know this looks weird. It's a weird distortion from the ratio of my computer screen to look like it got really elongated. I promise you that is that exact shape. If you look, take the shape, it's just playing a trick on our eyes. But I promise it's this shape, and when I turn it, reflect it over this line, that's our image. I know it looks like... What?
What are we supposed to write in tips when using tools?
Nothing.
Okay.
Okay. Name the line of reflection of the star. So we're just going to do some practice problems, and then we'll be done. Name the line of reflection for the star. So your line of reflection is not always going to be the x-axis, the y-axis, y equals x, and y equals negative x. It's not always going to be one of those 4, but you can name it pretty easily. One typed it and I saw. Good. So you want to find that line that is equidistant between the 2 stars. So first you find the line. Then you need to name the line. What axis is this line intersecting? It's intersecting the y-axis. And where is it intersecting the y-axis? At -2. Oops. So it's y equals -2. That is the name of the line. That's the equation and the name of the line. All right, try this one. The equation of the line of reflection. Of course, this one's vertical, so it's going to be a different axis.
X equals 4.
Nice. It hits the x-axis exactly at 4, so that is the name of the line of reflection. All right, let's do some matching. Take a look at these coordinates. What do you notice happened from the pre-image to the image? Well, x stayed the same, right? And y changed signs. So when y changes signs, that's a reflection over the, hopefully y'all are saying it, x-axis. Yes. Okay, what about here? What happened? Nobody changed signs, but they traded places. When the x and y trade places,
Y equals X.
yeah. And then, of course, we know what's left. But if we inspect this, nothing happened to the y, but the x changed signs. When the x changes signs, it's a reflection over the y-axis. Okay. 2 more problems, and then we're done, I promise. The coordinates of the image A is at 1, -2. After it's reflected over the y-axis and translated to the left 9 units, what are the coordinates of the image? That's what I was asking. So it wants you to take that point, 1, -2. It wants you to reflect it over the y-axis and translate it to the left 9. This is called a composition of transformations. It just means you're doing 2 transformations at once. So our original point was 1, -2. If I reflect it over the y-axis, I change the sign of the x. So now our coordinate is -1, -2. And now I want to go to the left 9. Left. Okay, so that's -9 to the x's, leaving us at -10, -2. So our answer, this middle step, is not part of our answer. It was just a step to get to our answer. Our final answer would be -10, -2, after doing both transformations. Okay, try this one and then we're done. So we've got 2, 5, reflected over the line y equals x, and translated up 8. So for the reflections, while you're still getting used to it, you're using your rules. And then for the translations, you're just using that good old common sense because you probably already knew how to do that. So what's our middle step? 2, 5 becomes Anybody know?
213.
Oh, I was doing our middle step first.
Oh.
So yeah, so we want to reflect it over y equals x. That's when you switch the coordinates. So that's our middle step. And then we want to go up 8, up 8.
510.
510. There we go. Final answer would be the coordinate 510. Those are the coordinates of the image. The first one's the pre-image, the second one's the image. Okay, so we're done.